Today's video will be about chemical reactions. The two reaction types that we're going to explore are synthesis reactions and decomposition reactions. You'll need to have several things out during this screencast. You'll need to have out a pencil, paper, something to write on, something to write with. You'll also need your periodic table, and you'll need the small packet that has the summary of reaction prediction on it. We're going to be going through A and B of that summary of reaction prediction. You may also need your polyatomic ion sheets as well. So in general, there are 5 different types of chemical reactions that we're going to talk about: synthesis, decomposition, single replacement, double replacement, and combustion. Today we're going to just stick with synthesis and decomposition. You'll need to, by the end of this unit, be able to identify the type of reaction and predict the products. Now, the summary of reaction prediction sheet that we're using as reference today will be reference material that you'll have on any formal assessments, so that sheet won't be taken away from you. You'll just need to be able to know how to use it. So for each reaction, you're going to need to first be able to identify the type of reaction. Then you're going to predict the products using the type of reaction as a model, and then you'll balance it. Things that you need to remember carefully are the diatomic elements, so that's Hofbrinkel. For example, oxygen is one of those. So those appear as Br2, I2, N2, Cl2, H2, O2, F2. In a compound, it's not diatomic because it's not just the element anymore. It's in a compound. So in a compound, you'll have to crisscross or use nomenclature to figure out how many of those particular atoms you have present. So a synthesis reaction occurs when you have 2 substances that are generally in their elemental form. They combine and they form a compound. Sometimes these are called combination or addition reactions. So you have one reactant combined with another reactant and it yields a product. The arrows didn't transfer over, so I'm going to draw them in for you. So basically you're going to have A plus B and it's going to yield AB. An example of that would be if you had hydrogen gas and oxygen gas and it yields H2O, water. Or if you took carbon and you combined it with oxygen gas and it yielded carbon dioxide. There are 3 types of synthesis reactions. So the first one that's listed on your sheet is where you have a metal and a nonmetal and it yields a binary salt or ionic compound. So in this case, let's do an example here. If you had potassium, so elemental potassium plus chlorine gas, so that's Cl2. And the salt of potassium and chlorine is going to be, so let's just do this up here. Potassium is K plus, chlorine is 1 minus. When you crisscross them, you end up with KCl. Now the third step, once you figure out the products, is to balance the reaction. So there's 1 potassium, 2 chlorines. In order to get 2 chlorines on the right side, you're going to put a 2 there. That throws off the potassium, so we're going to need a 2 in front of the potassium as well. This just shows the reaction, how it would actually take place. So if you took potassium metal and chlorine gas and you were actually to combine them inside of a flask of some sort, you would end up with a potassium chloride salt, and that's the white salt that we have pictured here. The next one is a metal oxide plus water. So the metal oxide is going to be whatever the charge of the metal is. Remember, oxide is just oxygen with a 2 minus charge. You're going to crisscross that with your metal, plus water, so water is H2O, to make the metal hydroxide. A metal hydroxide is going to have the polyatomic ion OH minus in it. So if we took a piece of sodium oxide, well, sodium is Na with a plus 1 charge, oxygen is O2 minus, and we add it to distilled water. So Na and O2 minus give you Na2O plus H2O, and it's going to make a metal hydroxide. Well, we've got Na plus OH minus, so when you crisscross that, you get NaOH. Now, we've got 2 sodiums on the left. On the right, we only have 1, so we're going to need a coefficient of 2. So then we have 2 oxygens, 2 oxygens, 2 hydrogens, and 2 hydrogens, so it's balanced. The third type of synthesis reaction is when we have a metal oxide. So again, with the metal oxide, you're going to have to do the crisscross, and oxygen is 2 minus. And your non-metal oxide, that's going to be based upon, figuring out the non-metal oxide and the ratio is going to be based upon the name. And these make ionic solids that contain a polyatomic ion. So again, sodium oxide is Na2O, and we combine that with carbon dioxide. And so, looking at your polyatomic ion list, the only polyatomic ion that you have that's got carbon in it primarily is going to be carbonate. So carbonate is CO3 with a 2 minus charge. And we've got our Na with a plus 1 charge. So you end up with Na2CO3. We've got 2 sodiums on the left, 2 on the right, 1 carbon on the left, 1 carbon on the right. 2 plus 1 is 3 oxygens, and 3 oxygens on the right. So try this practice on your own using the summary of reaction prediction, and see what you can do. If you want to work through the practice with me, keep playing. If you want to try this on your own, press pause. So here we have lithium metal. So this is lithium plus nitrogen gas. Nitrogen's diatomic. We know that's a gas. Metal implies it's a solid. So this is going to make a binary salt. We know lithium is in group 1, so that's Li plus 1. Nitrogen has a 3 minus charge, so we can crisscross them. We get Li3N. Now we need to balance. So we've got 3 lithiums on the right. To get 3 on the left, we put a 3 there. 2 nitrogens, so we need a 2 in front of here. That throws our lithiums off, so we're going to go back and have to change. And so we have 6 lithiums now, so we need to put 6 there. Now it's balanced.